зачем вообще это все нужно. Доклад будет на английском языке, мы об этом говорили. Если вдруг что-то будет вам непонятно, пожалуйста, записывайте в блокнот, и после этого можно будет задать вопрос, подойти к Александру Щербакову, нашему прошлому спикеру, он вам объяснит. И следующий спикер у нас Сергей Минаев, это разработчик компании DSR, техлид подпроекта Evernym. В IT-индустрии он также более 6 лет, учится в аспирантуре параллельно и пишет кандидатскую на тему распределенных систем. Сергей расскажет больше техническую сторону вопроса. И сразу скажу про следующий митап. Мы его планируем провести в середине марта. Приглашение вышлем вам на почту. Скажите, приходят письма, рассылка с анонсами приходит, да? Отлично. Я сейчас вам прочитаю тему, мне пришлось ее записать, извините. Обзор протоколов консенсуса. Рассмотрим задачу византийских генералов, проведем обзор протоколов достижения консенсуса, которые можно использовать в публичных блокчейнах. Я надеюсь, это вам все понятно, мне нет. Вот, ну, удачи. Сейчас передаю микрофон Ричарду. Вопросы давайте задавать после выступления каждого из спикеров. Вот. Потом не разбегайтесь, кофе-брейк, общение, обсуждение, пожалуйста. Ричард, we are glad to listen to you. Please start.
Thank you. Добрый вечер. That's all the Russian I know, so I'm going to switch to English. I do tend to get faster and faster, so if you stop understanding, raise your hand and say slow down, because I talk too fast usually. Who attended last time? Raise your hand. Wow, mostly new people. That's great. Well, welcome. Who has previously played with Hyperledger Indy? More than I expected. I'm surprised at the hands that didn't go up on the front, because I work with these guys. I forgot to move my slides over, sorry. Okay, so that's good to know too. So let me bring my slides over. Okay, so I am, as Anna explained, I'm Richard Esplin. I work with Evernym. I'm a product manager. Evernym helps people identify themselves online in a reliable, privacy-preserving way. And we help with that communication channel that gets established. We help innovative business models happen. So I'm responsible for the products that we contribute to the open source ecosystem that is Indy and Sovrin. And that's what we're going to talk about today, about how distributed ledgers have finally brought us a usable identity, and how that's an exciting thing. And I just want to confirm I have a half hour-ish, and then we'll spend a few minutes with questions and answers. Is that the idea? Okay. So what we'll talk about is, since 3/4 of the audience didn't raise their hand, we're going to talk about what is a self-sovereign identity, some about verifiable credentials, and then we'll talk about Hyperledger Indy and the governance that goes along with that. It's interesting through time to think about what is identity. When a king has a crown and a scepter, that's identity. The king has these symbols of his or her position in the community, and only people that know how to identify those symbols, recognize those symbols, it has meaning. And it's interesting that that ruler can discard those symbols whenever the ruler chooses and walk through the town as a commoner and nobody notices. Signet rings, kind of similar. It matters to the people that can recognize that signet, but it can be transferred to somebody else and passed along. Badges, uniforms, military medals, these are all ways that we identify ourselves and ascribe meaning to the role we play in society. Similarly, coins, that's kind of identity. It's showing that you, as the possessor of the coin, have some value that can be exchanged. And paper documents have identity. Whether it's a stamp that you attach to a paper document that says that you're authorized to send something, you paid for it to be sent, or a passport document, that's the government saying you have the right to travel. A university diploma, that's identity. It says that you've been through certain experiences that other people can have confidence have influenced your background. But you can also issue your own identity. Your business card, that's not necessarily issued by any authority. That's something that I've built myself that I want to give to somebody to let them know what I want them to know about me. These are all identity. It's also interesting, you can attach identity to an object. A license plate, you know, your car doesn't necessarily have that identity. It's identifying the owner. It's identifying the owner of the vehicle, but it travels with that object through space. So it's interesting that all this identity, we've used it for thousands of years. It works pretty well, but on the internet it doesn't work so good. There's the great cartoon, on the internet nobody knows you're a dog. The cartoon is copyrighted, but the Wikipedia page is fair use, so I can put that in my slide deck. But we have this trouble when we're on the internet of knowing that the person we're talking to is in fact who we think we're trying to talk to. So how do we solve that? Well, these great people have solved that for us. Facebook, Google, Twitter, LinkedIn. You know, you use their sign-in and everybody knows who you are. There's a problem with that though. They don't always treat your identity the way you would treat your identity. That data gets collected, it gets hacked, it becomes a business model, sold to the highest bidder, and it doesn't always end out well. It can be it becomes publicly embarrassing, but it doesn't actually drive behavior. These people aren't, their customers are not the users of the identities they service. Their customers are the people that are buying the information that's collected. It even ends up with regulation being implemented to try and control this behavior, the GDPR. In Europe, similar regulations exist in Russia and in the Americas, but we still see the behavior continuing. That's where the idea of self-sovereign identity comes from. This blog post from Christopher Allen a couple years ago summarizes what he considers to be 10 principles of self-sovereign identity. And you'll see most of these principles are trying to make a digital identity behave the way the physical identities used to, those paper documents. You know, it should be independent. I should have an independent existence of any vendor, because I'm me, it's my identity. I need to control it. It shouldn't be controlled by some third party. I should be able to access my identity and all the data behind it. It needs to be transparent. I should understand what's going on. Be able to inspect it the way I inspect a passport. It should be long-lived. If it disappears before I'm done with it, that's not a good thing. And the issuer of the identity can never know when I'll be done with it. It might have value for me much longer than they think it will. It should be transportable, as widely used as possible. I need to agree when it gets used. And I should be able to control what gets disclosed and minimize it appropriately. And my rights as the user of the identity needs to be protected. That's a pretty good summary of what's important in self-sovereign identity. It goes by a number of names: user-controlled identity, user-centric identity, bring your own identity. Gartner calls it bring your own identity. They're a major analyst. They say that the market for bring your own identity is going from practically 0 to 10% of all identity solutions over the next 18 months. They think it's just ready to explode. We'll see how that goes. But that's and it's going to continue to receive a lot of names depending on the vendor. It's a fairly new space. Part of self-sovereign identity is verifiable credentials. It's the ability to say, here's something that I want you to know about me. And you don't have to take my word for it. You can then go back to the issuer and find out it is what I said is true. Now, the challenge with verifiable credentials is when I give you my claim, you have no way to know if that's trustworthy. And that's where a public blockchain becomes so important, because you can then look at how that's signed and go back to the blockchain and say, oh yes, I know who signed this, I can trust this. And that signature can also say that I didn't tamper with that claim, I just gave it to you. But that you can have confidence that it is in fact what the original issuer said based on the signature they put on the public blockchain. So there's 3 components in this ecosystem. The issuer says, here's your diploma. You got an A+ in the class. I, as the holder, keep that diploma and decide whether or not I want to give it to anybody. I might give it to my car insurer for a discount on driver's rates. That's the way it works in the United States. I might give it to an employer. I might give it to a professor in my next class. I might give it to my spouse to prove I actually went to class. I can choose whoever I give it to. There's no way that the issuer can control that. And then the verifier, who I give it to, they can go back to that public blockchain and say, yes, this is in fact valid, it hasn't been tampered with. Now it's important to recognize that I don't want my information on that global blockchain. Because blockchains you can't delete from a blockchain, that's kind of the point. And my information is private. I don't want that shared with the world. So when I have that relationship with the issuer, that's going to be a private identifier. And I can rotate that identifier. I can have as many as I want with an issuer. And I want to make it hard for that issuer to combine that identifier to figure out where I'm being, to track me across the interactions. Similarly, when I talk to the verifier, I can have my own relationship there as well. So those private identifiers are called DIDs, decentralized identifiers. It's a W3C spec, World Wide Web Consortium. And when we have these exchanges between the issuer and the prover and the verifier, we want to do that using zero-knowledge cryptography. And Sergey's going to explain a bit more about how that happens. But the summary is, I can tell you something's true without you finding out exactly what it was. Or I can tell you something's true without you finding out the specifics. I can say, I am over 21 without telling you my exact age. I can say, I am an American without giving you my address. That's zero-knowledge proofs. Where the issuer says, this is Richard Esplin's exact address, but when I give it to the verifier, it just says he's an American. Let's explain that in a bit more detail. Let's make it concrete with a use case. I have an empty aquarium. I want to buy a fish. But I don't just want any fish. I want an environmentally friendly, certified, safe fish. A fish that's sustainably harvested or raised. How do I find that? Well, I go to the web and there's a vendor sells pets that are friendly environment. How do I trust that claim? Well, there's a verifier story QR code. So I pull out my phone. I've got Evernym's wallet on there. Some product that allows me to check that claim. I take a picture of the QR code, and I see credential from Marine Stewardship Advocates. This group did an inspection. I do some web searching. They look trustworthy. Okay, I can trust that. I'm going to buy the fish. Well, okay, I do another QR code. Now I have a direct connection. This connection is not mediated. It's directly between me and Elias International. This company can now communicate with me directly. And when they communicate, I know who I'm talking to. It's not a random email that can be spoofed. It's signed by the keys that I've checked. My delivery is going to be done by Speed Delivery Incorporated. They can act on their behalf. I get a credential proving that relationship exists. Well, but I'm in Russia. How am I going to get my fish? Well, I have a box on my porch. So I'm going to put this credential I got into the box, and it says, when somebody comes from Speedy Delivery, they can get access to the box. Well, that's great. But I got an update. It's changed. The new delivery service. So now I know, this came definitely from Alias. It wasn't forged. That company goes ahead and revokes that original certificate. Speedy Delivery is not going to do it. They give me a new one, Global Fish Delivery. Now I can go through and revoke the certificate in my box and put a new one in, Global Fish Delivery. So that's great. And when the delivery person comes, that specific employee can prove they're an employee of that company, so they get access to the box. They put the fish in, and that employee walks away with a certificate that says they in fact put the fish in. The box issued it. So they can prove that they did their job. That's nice for everybody. But wait, I'm here for a while. That fish is going to die in the box. So I need my neighbor to pick it up. So I give my neighbor access to the box one time. But, they're my neighbor. They're watching the place when I'm gone. They can't have access to my front door as many times as they want. So I give them a certificate. It works on the front door. They can get in. If something goes wrong, I don't like what's going on, I can revoke that. And my fish, they can go plop in the fish tank. And I've got a happy fish. So that's the idea of verifiable credentials. The nice thing is it works in a lot of different use cases. What I like about this use case is you have the main issuer of many of these credentials is me. I don't have to go to a third party. There's a lot of value in just me being able to tell people what I want to trust and what I don't. Now, in order for this to work, you have to have that public blockchain. That's where Sovrin comes in. Sovrin is a purpose-built public blockchain, a global utility. And the goal is that anybody in the world can be able to look up these keys to verify the credentials they receive. And it's tailored for privacy-enhanced self-sovereign identity. It's based on Hyperledger Indy to do that. So Hyperledger Indy is an open source project. We're going to talk about that for a minute. It's a public permission blockchain. When you look at most blockchain technologies, they're public, but they're not permissioned. And because they're not permissioned, you have to have some sort of proof that what got done really got done, a proof of work. It can be, apologies, it can be not, that proof of work takes a lot of energy, it can be environmentally challenging, and it takes a lot of time. And Sovrin is permission, meaning that the validator nodes are all involved. We give permission to who gets to be a validator node, and because of that, they can follow a different protocol that is less resource intensive and can be more performant. Again, this is custom built for identity. That backend protocol we're using is RBFT. That could change over time, but that provides a consensus between those 25 validator nodes that can serve the world. And then you can have other tiers of read-only caches, things like that as it grows. There are a few key pieces to Hyperledger Indy. URSA is the cryptography library. And the Indy project, most of the people that wrote URSA are in this room. They helped build it for Indy, and then Hyperledger, I should actually check. Who knows what Hyperledger is? Raise your hand if you know what Hyperledger is. Okay, let's describe Hyperledger. Hyperledger is a project of the Linux Foundation, and so it provides governance for various corporations to interact together, and it provides that for private blockchains. So Fabric and Sawtooth and Burrow are major Hyperledger projects. Most of these are meant to be private blockchains. So unlike Bitcoin that covers the entire world, or Ethereum that's public for the entire world, major corporations might want to have a blockchain that's just for them. Or a group of insurers might get together and have a blockchain that's for 4 or 5 different companies. So it's a very different use case. Hyperledger mostly does those private blockchains. Indy is an exception to that because Sovrin's decided to deploy that in a public way. So they looked at the cryptography library that we built and said, hey, we want to use that for all of our projects. So it's a top-level project now. It's kind of exciting. It's used by the SDK, and it's also used by Plenum. Plenum is the implementation of the consensus ledger. And Node is the actual server that runs that ledger. My team's not grimacing, so hopefully I didn't make too many mistakes on here. The SDK is how we interact with that. The SDK has a few key pieces. libindy actually talks to the ledger. VCX provides credential exchange. It simplifies a lot of the additional communication that's required to do that issuer, verifier, holder exchange back and forth. libnullPay explains how you can add payments to credentials. It doesn't actually implement the value of the transfer value, but it shows where those API plugins can go, so you can create plugins to Node, or to Plenum really, that can do that value transfer. And then it provides a wallet for containing the credentials that get issued. On top of that, there's language-specific wrappers, and then on top of the wrappers, you have agents. So the agent is what's actually running on my phone. Now, the problem with what's running on my phone is that sometimes I turn my phone off, sometimes I get on a plane, sometimes I do things, and I don't want to disappear from the world. So, in addition to my edge agent on my phone, I might have a cloud agent. And that cloud agent can cache messages, and when my phone appears, it'll make sure it gets to me. And there's also thin agents and static agents, where on my phone I might have additional apps that want to talk to my wallet, my main edge agent. And I might have a static agent that knows how to do only one thing. So that's your Internet of Things sort of use case. You know, that box on my porch, it doesn't know how to do multiple connections. It doesn't know how to tell a lot of different things. It just knows how to do one thing. Are you authorized to open the box or not? So it's a static. It just has a key and one action. So that's the ecosystem that makes up Hyperledger Indy. Again, this is tailored for privacy, for preserving privacy. Correlation is the problem that we're trying to fight against. Correlation is the ability to link your identity across the various actions you take. You should be able to control how you present yourself to the world. And correlation is when that investigator follows you around and takes notes on everything you do, and then can tell some third party, oh, this is how this person behaves because we've observed them. And there's some key vulnerabilities here, some key ways that correlation can be done. If I tell somebody all the time my address, that attribute can be used to correlate. You can figure out a lot of things from my address. You can probably figure out a range of my income. You can probably figure out a range of my race. You'll definitely figure out my citizenship. You can probably figure out how I voted in the last American election based on my address. The identifier-based correlation, my IP address is tied specifically to me. So if I give somebody my IP address, they can track me all over the internet. Similarly, your driver's license number, your passport number, things like that. So we want to be careful about those identifiers. Similarly, a hash of an IP address can still be tracked because theoretically it's going to hash consistently, and that signature or the hash can be correlated across your interactions. You can also make inferences from timing. If people see that I check in at the same place at 10 o'clock every night, that's probably my house. I might not have told you anything else about it, but because you saw the time that I uploaded that photo with an IP, with a latitude and longitude, you know that's probably where I live. And one of the challenges we need to defend against is we might defend against each of these in an individual transaction. But if I have worked with an issuer and they shared their information with the verifier, those two groups can collude, can work together to figure out who I am. You know, if the issuer says, well, I issued a passport at such and such a time, and that passport got used in a similar location at such and such a time, well, that's probably me that took the passport from one place to another. So we need to make sure that we can prevent that information from being useful even when it's shared to a third party. And again, that's where Sergey's talk comes in handy. In order to achieve this, we give the user certain privileges. The user, the prover, gets to choose when to disclose. You can't compel me to give you my identity. Frequently, you'll ask for something. In the app, it'll say, you know, your bank wants to know your address. And then you can choose, do I give my address or not? Similarly, the prover should select what gets disclosed. I should be able to say, yes, I want to give you my city and my state, but not my house number. I shouldn't have to share more precision than is necessary. I can tell them I'm over 20, but I don't have to tell them my age. And I can verify that the issuer and the verifier don't communicate to each other. When I give the verifier my credential, they can see that's true without going back to the issuer. And so that issuer has a harder time correlating with the verifier to track information that I want to track. And I should be able to use that credential with anybody I choose, not just with some pre-approved list. Similarly, I can give you a credential that's different from what I received. I might have a credential from my state that says my address, but have another credential from my library that says I have a library card. And then I can give you a new credential that says I'm allowed to get books from these libraries. Because without having to tell you my address or what library I got the card from, I can combine that information and give you something slightly different, but you can still validate that each item is true. And it needs to be revocable in an anonymous way. If the issuer says we're revoking that people can't see exactly what got revoked. But when I go and share my credential, they can see the credential is no longer valid. Those are the steps we take to ensure privacy. It's important to recognize that when you build a technology, you need to pay attention to the environment in which it's getting used. It's much more than code. That's one of the main problems with blockchain today, is people have created these different ledgers, and they haven't paid attention to how it's governed. And all software is governed, especially a blockchain or an open source project or a distributed ledger. There's governance around this. There's decisions that need to be made. And if we don't decide explicitly how those decisions will get made, they will get made in an implicit way. And they might not be decisions we prefer. You see a variety of blockchains, there's a variety of governance models. And some blockchains have more than one governance model. Open source communities make decisions around how the code's going to work. Algorithms encode how that will behave. And governance frameworks determine how people will interact with those. And one blockchain can be in more than one of these. It can have more than one of these models. Most blockchains probably have most of them. And we want to explicitly decide how these work, especially when the technology is controlling our lives, our society, to the level that an identity system would. And that's when democracy starts to get threatened if we're not careful. Bruce Schneier is a cryptographer and a security analyst. He's a blogger, Schneier.com. It's a great blog. Highly recommend anybody who's interested. he talks about the systems that we create and how they get subverted. And one of the challenges we have is trusting anything in society. We go through most of our days trusting people and it works out. But how exactly does that trust work? How do we enforce it? And he has a great book called Liars and Outliers, Enabling the Trust that Society Needs to Thrive. The basic idea is that we create governance systems that should prevent liars, prevent people that are defecting in terms of game theory, that are preventing people from abusing our trust. But similarly, we want our systems to allow outliers. You know, Jesus, Gandhi, civil rights activists, these people are making society better, and they're usually breaking the rules in the process. And so we need systems that allow society to improve, but still protect us from people that are causing trouble. And he says there's 4 ways to do that. We can apply moral pressure, reputational pressure, institutional pressure, or use a security system. And one of the problems that we frequently see in society is we try to apply that pressure at the wrong tier. We say, hey, here's your cryptographic solution to copyright management, your digital rights management system. And it doesn't allow things like fair use. And so we've subverted democratic controls over the way copyright works. Or we say, you know, the red light when you drive through it is automatically going to give you a ticket. And we've given up having the cop that makes the decision, well, you know, you're driving to the hospital because you're injured, so we're going to let you go through this time. There's certain negotiation we make as humans that we want to make sure our technology preserves. And similarly, there are a lot of things that currently require a lot of contentious argument that if we put in technology would save all that hassle, because we've all decided and now it's coded and we've made the decision. And we need to be careful where we select these things. So we call that the BLT, like a sandwich, bacon, lettuce, tomato. The business, legal, technical. We need to make sure we pay attention to all 3 tiers in order to have a solution that's meaningful in society. Sovrin solves that with what we call our governance framework. And we have a set of stakeholders. They come together and they say, this is the framework in which we're going to participate. Validator nodes will follow the following rules. We will respect credentials in the following ways. We will issue credentials in the following ways. We will only use the Sovrin trademark if we are respecting privacy in the following ways. And so creating this governance framework allows that trust to occur. Similarly, every user of Sovrin, every user of a verifiable credential has to decide what they'll trust and what they won't trust. And so you'll find different tiers of governance frameworks. There's probably a governance framework just for insurance. There's a governance framework just for insurance in Russia. Just for diplomas of computer science in a certain state, in a certain province. And so this determines interoperability, and it determines what you'll trust and what you won't, and it feeds into the business model that benefits from that trust. As a result, digital credentials are only as good as the trust framework. If you don't have a trust framework, then digital credential isn't trusted. There's no point in issuing it. Our Chief Trust Officer, Drummond Reed, he likes to talk about how digital credentials intended to serve more than one issuer verifier. If it's gonna be used more than once, it needs a governance framework because it's more than a negotiation between 2 parties. This governance framework needs to say what issuers will give out the credential, because we don't want to trust a credential from just anybody. What credentials are allowed to be given by that issuer, and what policies will govern that credential in order to achieve that trust. If I go to the airport, I can't use the credential I issued myself that lets me go through. I have to have a credential issued by somebody that the security officer of the airport is going to trust. And that's a governance framework. So as a result, Evernym is building products that worry a lot about these things. Digital identity requires an open source option so that you know you're in control of the technology that implements credentials. It has to have open standards so you can share it with additional people. We want to make sure things are private by design to respect that self-sovereignty, and private by default, so that it shouldn't take a lot of messy configuration to add that privacy. And have to have a trust framework to make sure things work. That is the crash course of Indy and verifiable credentials. Top-level Hyperledger project. But one of the challenges we have is all these agents are controlled by an individual. I control my edge agent, I control my cloud agent, my thin agent, my static agents. But how do you start an ecosystem? You've got to be able to have a set of credentials in the world that people can start using in order to exchange credentials, so that the agents I control have somebody to talk to. And so British Columbia and Canada started with Catalyst. They just said, hey, we can issue credentials to any organization we want in our province. So they have what is called the org book, an organizational book, and it contains the business license credentials for everybody in the province. And they hold those credentials on behalf of these businesses, and when these businesses decide they want to control their own self-sovereign identities, they can claim those credentials and import them into their agent. So that's Catalyst. So thank you, I totally missed that. So it's an organizational agent. It's an agent that's held on behalf of a third party holds on behalf of the self-sovereign identity. Very good, thank you for that. You're going to go through the stages of saying, yes, I trust you more. You've proven that you're willing to, you have a job, you've proven you're a nice person, you've proven that you're not crazy, and gradually go through this process of saying you're going up through tiers of trust. And as you exchange these credentials, your agent will hold all those credentials. So you can say, yes, this is a connection that I trust much more than that other connection with some random spammer that's misusing my email address. And you can decide, this is a bank I've used for 20 years. I have a different relationship with them than this new person that just knocked on my door because of the history that's shown up in that agent. Excellent question. Next question.
Thank you. What should be hardware resources for running this algorithm? I mean, what about constrained devices? Did you consider using constrained devices for these algorithms, or we need some big machines, servers, or whatever?
Yeah, it depends on the part of the ecosystem that you're working in. The reason why we created the idea of a static agent is this is your embedded device, your very constrained device. All this has to do is hold one key for one connection to prove one thing, and attach to that one connection a data packet of some sort. Thin agents, in addition to that, they can have multiple connections, but they don't have to have a wallet, because they're going to interact with the wallet in the edge agent. The node that's running the back-end global utility, that's got to be pretty beefy. But your agents really depend on what your use case is, how beefy it's going to end up being. The edge agents we're building, they're living on your mobile device, and they're definitely, we target older platforms of Android and iOS, so any phone made in the last 3 years runs the edge agents pretty well in the last 4 years.
Actually, the background of my question is, if you think it's possible to use these algorithms in, say, IoT, when I have several constrained devices which would like to talk to each other, and obviously they are pretty constrained on their resources, I mean, RAM, flash, CPU, power.
Yeah, that role of devices interacting directly, so there's different levels of that communication. So Plenum and Node was not written to run on a constrained IoT sort of consensus algorithm. Wouldn't be recommended there. But when you have these static nodes, these IoTs, the idea is that they're going to talk to a cloud agent that's going to be able to route these appropriately. So when you have a set of, a smart home, you've got 1,000 devices in your house or whatever, they're all going to talk to your cloud agent to make sure that the messages get to the right places, have the manipulation that are needed, and then those credentials can be provided to your edge agent for you to use appropriately. What was your second question?
Thank you. I want to ask, what are the key differences between the catalyst and the node? As I understand it, the catalyst is a credential store, and in my understanding it is a node too, but it's drawn on the different parts of the tree.
Yeah, good question. So the node is completely separate. This node runs that global ledger. And that is the only thing that node does. So as we pop back here, this is the set of nodes. These are the agents. And the catalyst is a specific type of this that contains a wallet that can be handed back to the third parties. So it actually doesn't have anything to do with, well, I mean, it uses the node, but it isn't a node. It's much closer to these agents because it's using the SDK to talk to the node, and it's presenting credentials that agents can consume And then anybody who says, yes, I want to take control of the keys that are in my org book, I can take control. So it's probably running on the web, just like your cloud agent will. But it's not participating in consensus. It's not part of the ledger. Excellent. Well, that's probably the time that we have allocated for questions from me. If you have more questions, I'll be around after Sergey's talk and we can talk more. But Sergey's describing zero-knowledge proofs is going to be really interesting. So, is there any last question?
It's possible that this technology someone will replace plastic cryptography like we have with RSA and other public things.
So this URSA is the cryptography library that powers it all. And it's got a variety of encryption algorithms there. Currently we mostly use RSA. We're moving towards elliptic curves.
Right.
They're quite a bit faster, but there's specific elliptic curves that we're trying to target that are fairly new. So yes, it can take advantage of the latest cryptography, and yes, the zero-knowledge proofs that Sergey is going to talk about are pretty innovative in the in how they do their proving. It's a bit different from like classic Diffie-Hellman or whatever, but there isn't anything specific in the consensus algorithm that requires anything unusual. There's just advantages to performance to move to different kinds of cryptography.
So is my understanding right that you're using certs and this algorithm as a building blocks for a system?
Yeah, so the transactions on the ledger are signed with an RSA cert.
Elliptic curves.
What?
Elliptic curves.
Oh, elliptic
All
curves.
transactions are signed by elliptic curves.
Okay, Sergey knows better. Alex knows way better than I do. So elliptic curves on the ledger, and then each of the claims is signed as well, is digitally signed as well. What gets really innovative is when you do that mixing and matching claims. You say, hey, I want to share a credential from my university, this attribute from the credential from my university with that attribute from the credential from the state, and I'm going to give you a new proof that combines those. That combination, and I'm going to make it fuzzy. Instead of giving you the exact information, I'm going to say, yes, I did in fact live in one of the following cities, but I'm not going to tell you which one. Those kind of, that kind of zero-knowledge proving is very interesting and very powerful for preserving privacy. Because then you can start to say, the other part of that zero-knowledge proof is, you can then say, oh, well, this was what I was trying to figure out, so I have the information I need. But if you then try to give that proof to somebody else, and say, oh, I know that Richard lives here because he told me. Well, that proof's not going to do any good there, because once you take it out of that context, it doesn't have any meaning. It just says one of these 12 cities. So Sergey will go into that in more detail, but that's where the meat of the interesting encryption work is.
Right, but if we still use the certs and we need to check it, is there a problem of having the root, checking the root of trust, like root certificate?
So the certs are signed by the key that's on the global ledger. So you don't have a certificate issued by a central authority. The nice thing about a public ledger is it removes the need for a certificate authority. And each verifier, each issuer is going to issue things signed with their own key. And so you can decide, do I trust that issuer and do I trust their keys or not? And so compromising one issuer only invalidates that issuer's credentials. It doesn't impact anybody else. And you can, at any point in time, you can say, hey, I'll trust that random certificate for this action because, I don't really care buying an Apple. But when I'm buying a house, I want a higher level of confidence. And so it's not as binary as today's certificate authority PKI infrastructure. It's much more fine. It's much more like the paper credentials we started with, where any specific paper you get, you can say, yeah, that looks like a power bill. I'll trust you. I'll trust that means your address for this use case. But you want another use case? Yeah, I'm going to need to send somebody to your house and verify things. It totally depends on your use case, what you want to trust. So very good questions. Thank you for your time, and I appreciate all. Spasibo.